This is the screencast for section 5.5, example 1. We're going to look at the trapezoidal rule. The trapezoidal rule is very similar to the RAM we did in the very first section in chapter 5 here. But instead of using rectangles, we're now going to use trapezoids. As you can see from the picture, they're a little bit more accurate. They don't have a ton of overlap or a ton of underlap, I guess. And if, of course, the narrower they get, the more accurate they would be. We can look at the trapezoidal rule in a few different ways. It's up to you what you prefer to do with the trapezoidal rule. But our ultimate goal here is also to understand that the trapezoidal rule is the average of the left RAM plus the right RAM because it's average of the bases times the height. Now the trapezoidal rule all means the same thing, but what I mean is you can choose which version you'd like to use. So for example, you can choose to calculate each and every size of the trapezoid, which is how it's laid out here in step 1. Or you can look at it as, well, let's take the denominator and distribute to each and every single piece. So y sub 0, the first height is being used once, but then every height after that is being used twice, except for the last one. So now I can simplify that into, if I'm using half of y sub 1 twice, so once for, like, if you look at the picture over here, once for trapezoid 2 here, and then once for trapezoid 3, well, then if you're using it twice, half of it twice, you get a whole y1, whole height. It's just the ends that you would only still be taking the average of, or dividing by 2. And then if you want to factor out the 1/2, you get h over 2 on the outside, and then y sub 0 is just by itself, and then you can double each of the inside heights of these trapezoids. Of course, not y sub n again. So in example 1, I'll show you what that means in kind of more of a concrete situation. We're going to use the trapezoidal rule with n equals 4. So we're going to divide this area into 4 trapezoids, and we're going to estimate the area under the curve from 0 to 2. Now, unfortunately, my picture here has it from 1 to 2. So I'm going to show you a little bit more of a concrete example here. We're going to use the trapezoidal rule with n equals 4 to estimate the area under the curve on, and we're going to do 1 to 2 because that's how the picture is drawn. So I'm changing the problem a little bit. So we're going to do from 1 to 2. So I'm dividing that into 4 different trapezoids. Okay, so I will show you the first phase where you could just simply calculate each of the 4 trapezoids. So my first trapezoid is the average of the bases times the height. Base 1 we called p sub 0 in the picture. Base 1 we called p sub 1 in the picture, and so the average would be add them up, divided by 2, and multiply by the height. The height from 1 to 5/4 is 1/4, because we divided the space between 1 and 2 into 4 trapezoids. Now 1/4 times, this will be the next set of bases, p1 and p2. Then we have 1/4 the same height or width, however you're determining this, because it's kind of sideways, and then we're using height p2 and p3. And then P3 and P4. So you can see that P sub 0 is used once and P sub 4 is used once. Everything else is used twice. So now I'm going to factor out the 1/4 just to make my writing a little bit simpler. Now I can distribute this denominator to each and every single one. So I have P sub 0 over 2 once and P sub 4 over 2 once. Everything else got used in 2 different trapezoids. As you can see by the color coding, I made the first trapezoid black, the second trapezoid green, etc. So now I combine like terms, p sub 1 over 2 plus p sub 1 over 2, so half and half is a whole p sub 1. So I simplified here in this step. But I still have this over 2 for p sub 0 and p sub 4 because the other half of those was missing, I guess. Well, remember, p sub 0 is a height of a curve. It is f of an x value. So p sub 0 is actually f of 1, the function's value after I plug in 1, so 1 squared in this case. P sub 1 is f of 5/4. P sub 2 is the function's height after plugging in 6/4, and then 7/4, and of course 6/4 is 3/2, and then 2. So I did 1 squared, 5/4 squared, 6/4 squared, 7/4 squared, 2 squared, and I get about 2.34375 square units. Now yes, in here you could have factored out the 1/2, which then would have given us f of 1 by itself, but f of 5/4 divided by 1/2 is the same thing as f of 5/4 times 2, so 2 f of 5/4. So I'm doubling all of the inside ones, but a single f of 2 and f of 1. So here's kind of your different phases of the trapezoidal rule, whichever one you would like to utilize, and sometimes it'll depend on the situation. You're more than welcome to do that. The now try problem number 3 asks us for A, to use the trapezoidal rule with n equals 4 to approximate the value of the integral. Alright, well I can do that. Let's see, this from 0 to 2 of x cubed. Well, I know x cubed looks like this, and we're going from 0 to 2. 2 cubed is 8. So that point up there would be 2, 8. It wants us to do 4 trapezoids. So that means my x values that I'll be using are 0, 1/2, 1, 3/2, and 2. 4 different trapezoids in there. Now again, you can choose. We're going to approximate the value of this integral, so you can choose whether you want to calculate the area of each trapezoid separately. I'm going to use what I think is the simplest form of this. And I know we don't generally like fractions, but here's the thing. If I use the other one where I factor out the 1/2, I would have to double 3 different numbers, as opposed to here I only have to divide 2 numbers by 2, so that is why I chose this one. Alright, so then I have f of 0, 0 cubed, which is 0 over 2. F of 1/2, that's 1/2 cubed. 1 cubed. 3/2 cubed, and then finally 2 cubed, but over 2. So after some wonderful adding of fractions and reducing, I mean this is 0 plus 1 plus 4, which is 5. This is 28/8. So I get about 4 1/4, so 4.25 square units. Now that's my estimate. That's part A. Part B says use the concavity of the function to predict whether the approximation is an overestimate or underestimate. Well, the concavity, this is going to be concave up. So my trapezoids are going to overestimate, and you can kind of see in my drawings there's a little bit of white space in there. It's an overestimate if you want to magnify it or exaggerate it. If something that's really concave up, if you draw a trapezoid, the top of that trapezoid is going to overestimate the area under the curve. Now part C says find the integral's exact value to check your answer. Okay, so part C, find the integral's exact value. I'm going to do that by hand. Yes, I know I can use my calculator, but let's practice without. So I'm going to find the antiderivative from 0 to 2 of x cubed dx. So that's going to be, let's see, the antiderivative of x cubed is 1/4 x to the 4th, and I'm evaluating that from 0 to 2. So that means I want 1/4 of 2 to the 4th minus 1/4 0 to the 4th. So that's 4 minus 0, which is 4 units squared. And as you can see, our trapezoidal rule definitely did provide a little bit of an overestimate.